In this lesson, I'm going to help you figure out your linear programming notes. Some key things to review before is to how to graph an inequality that looks like this. Let's say I want to graph the inequality that says x is greater than or equal to 8. There's only one variable involved, and that is just x. So to graph this, anytime you only have x as the variable, it's what we call a vertical line. And maybe you want to make a note of it and draw an example like this. So x greater than or equal to 8 means I'm going to count along the x-axis. 5, 6, 7, 8. This is where x is equal to 8. I can make a point or whatever I want to do. And my line is going to be a vertical line at x equals 8. That's hard to get perfect, so imagine that I am right at 8 and my line is perfectly straight. So here's my line. Now it's an inequality, so I got a shade. Well, which side are the numbers bigger than 8? Hopefully you thought that the numbers bigger than 8 are off to the right side. If we wanted to graph y is less than 3, well, this is a horizontal line. So I'm going to go up to 3 on the y-axis. And my line is going to be this horizontal line straight across. And it is less than 3, so my shading would be all the numbers less than 3, which would be down below. So we're going to have these types of examples in these notes that we're going to graph. With these linear programming problems, you're going to have to, number one, graph the constraints, graph those inequalities, determine the shaded region, determine the objective function, and then test the corner points to give us our maximum or minimum. So let's get right into example number 1. It says Mike helps run a butcher shop. He's in charge of selling steak and chicken. Each week he must prepare at least 8 pounds of chicken and at least 6 pounds of steak. Combined, he can produce at most 20 pounds of meat each week. If Mike makes a profit of $4 per pound of chicken and $7 per pound of steak, how many pounds of each type of meat should Mike prepare each week? Well, number 1 says we have to graph the constraints. So in these problems, the constraints are labeled within the word problem, but they're also given to you. So x is chicken, y is our steak. Our first constraint is x is greater than or equal to 8. Okay, well, we've already practiced graphing this. So I'm going to go over to 8. Okay, and I'm going to draw a straight up and down line. I know that this line's at 8. And I'm going to shade to the right. Okay, next one, I'm going to graph y is greater than or equal to 6. For y is 6. I'm going to draw my line straight across. You can do so with me. Pause it if you need to. Y is greater than or equal to 6 means I need the values bigger than 6. Well, that's going to be shading above. Okay, and my last graph is this x plus y is less than or equal to 20. Well, this is in standard form where I need the x-intercept, which is 20 divided by the number up front of the x. So that's just 20. The y-intercept is 20 divided by 1, so it's the same thing. The y-intercept is 20 as well. So let's count up to 20. So we've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20. And we've got 9, 10, 11, 12. There's 20. So the x-intercept is plotted. The y-intercept is plotted. And now I'm going to do my best to get a nice straight line. Choose a color to connect. There is my line in red. Now we got to figure out the shading. Remember that we want to pick the point 0, 0 and figure out if we're going to shade towards, down towards 0, 0, or away from it. So if I plug 0 for x, 0 for y, I get this statement, 0 less than or equal to 20. This is a true statement, so my shading I'm going to shade below. And now I need to look where does the shading overlap. Where the red, blue, and green intersect. So my shaded region where all three intersect is right here. And I'm going to darken that. So if you need to pause it, go ahead. In which, there's my feasible region. We just determined the shaded region, part of the problem. So here's what I'm going to do. If you need to come back to it, you can always erase the video. I'm going to erase this part. I'm going to leave the graph because I need space to do the next part of our problem. So we need to determine the objective function. So I need to read through the problem and figure out the objective. Well, the objective in these problems is to make a profit. So that means our objective, it's typically towards the end of the problem. It typically involves our profit. If we make a profit of $4 per pound of chicken, that means we make $4 for every pound of chicken we buy. And we're going to add together the money we make with steak. We make $7 per pound of steak. So our objective function is 4x plus 7y. Bam, we determined our objective function. The last step in these problems, after we've graphed, after we shaded, is to determine these corner points that we need to test. Now your graph, it's going to be much easier to tell. My graph, I know that this corner point is 8, 6. This corner point's not going to be perfect on my graph, but I know that the y value is 6 and the x value is 14. Up here, I know that the x value is 8 and the y value is 12. So we're going to test each corner point to determine the maximum profit, because we always want to make the most. Well, 8, 6, I know I don't even have to test that corner point, because 8, 12 and 14, 6, they're both going to be bigger. So to test 8, 12, I'm going to plug 8 in for x and 7 in for 12 to determine our objective. So we're going to take 4 times 8 and get 32 plus 7 times 12, and 7 times 12, that gives us 84. Add those together and we come up with $116. Now we need to test 14.6. So I'm going to plug in 4 times 14 plus 7 times 6. 4 times 14, that will give us 56 plus 42. 56 and 42 would give me 96, which Mike should prepare 8 pounds of chicken, 12 pounds of steak for a profit of $116. That is what we need to write as our final answer. So I'm going to erase this real quick. My final answer is going to be written right here in green. So he should prepare 8 pounds of chicken, 12 pounds of steak. Profit equals 116. What I'd like you to do is try number 2 on your own. And when you are finished, before you turn this note sheet in, check your answer with Mr. Ryan in the end. And if you need help with number 2, call him over and ask for help.